Okay, 4.8, there's a rubber stopper, has a mass of 0.013 kilograms, and we're going to swing it around in a circle above our head. It's at the end of a 0.850 meter long cord. So that is actually the radius, because that cord will be going from your hand out to the rubber stopper. So that'd be the radius of the circle that you're spinning it around. With a period of 0.650 seconds, that means this is how much time it takes for the rubber stopper to go around the circle one time. That's not the velocity, that's just the time it takes to go around one time. If you wanted the velocity, you'd have to take the circumference of the circle divided by this time to find the centripetal force. So we're going to start with our centripetal force equation. F equals mv squared over r. And we're going to divide this up a little bit. We're going to do m times 1 over r times v squared. So we can make it look like that. Okay, so I'm going to have mass times 1 over r times, and what is the v? Well, the v is distance over time. And how far does it go around one circle? That would be 2 pi r over the time period, which is the period. Now that whole velocity is squared. So m times 1 over r times 4 pi squared r squared over t squared would be the velocity squared. And then you'll see we have an r here and an r up here. It's going to cancel one of those r's out. So we're going to get m times 4 pi squared r all over t squared. Okay, so that'd be the mass was 0.013 times 4 times pi squared times the radius, and the radius was 0.850 meters, and that's all over the period squared would be 0.650 squared. So I'll try to do that on the calculator real quick here. 0.013 times 4 times pi squared times 0.850 divided by 0.65. Let's see. Sorry, I messed up. Squared times 0.850 divided by 0.650 squared equals, and we get a force, a centripetal force of basically 1 Newton. 1.03 to be exact, I guess, with 3 sig figs. But basically 1 Newton of centripetal force is what it takes to spin that around at that speed.